So we are here. We are here to present the PRYSM project. Okay, this was made by Pulverizadores Rocha and Dinesh Tech. And our agenda for today, it's a welcome session. And we will start with a presentation of partners of this project, okay, 10 minutes. And then we will have 10 minutes for presentation of the PRYSM concept, okay, the PRYSM prototype. And afterwards, we will have a live demo, okay, where you can see, you will be able to see the robot and interact with the interface that we have made available online, okay? So let's start with the Rocha presentation.
Hello, good afternoon. I'm Sergio from Rocha, and I will make a short presentation of the company, okay?
Okay.
The company was founded by Joaquim Dias Rocha in 1946. We start with the production of manual neckpack sprayers under the brand of Rocha. Currently, we are a symbol of quality, offering innovative solutions that are extremely efficient and ecological in terms of sprayers, fertilizer spreaders, and vineyard equipments. Our main products are sprayers, spreaders, and winery equipment. I will show you here a few examples. In sprayers, we have field sprayers that works with booms and also mist blowers for vineyards and orchards. In terms of spreaders, we have a wide range from small machines until big machines to big fields. And in winery equipment, we have trimmers and prep runners, okay? These are our main products. I will give you a short historical evolution of the company, okay? Until 2000, Rocha in 80s with a new board of directors grew and become even more competitive and innovative. After 10 years, we start the production of fertilizer spreaders, okay? Because on the beginning, like I told you, we only produce sprayers, okay? And it was in the 80s, 90s, more or less, that we start with the production of fertilizer spreaders. Between 2000 and 2015, Rocha becomes a limited company, okay? And we start with the professionalization of all the company, from the management until the production. We start a new business with the winery equipment, like I told you first, trimmers and prep runners mainly, and the company continues invest in develop. But during this period, between 2000 and 2015, we was the focus on internationalization, okay? In this year, we saw some limitation in the production. Basically, our demand was bigger than our offer, and we have to reorganize all the plant. We invest in a new warehouse, and we start with the production based on lean manufacturer principles, okay? With this, give us the increase of the production and creates conditions to spread a little bit the brand Rocha all over the world. Okay, now with the production, with this kind of organization, our focus is on R&D. For the future, of course, our focus now is on R&D. We will search for new products, more sustainable. We will invest also a lot in precision farming, and of course we include here the agriculture robots. For the future, our main target is to develop a lot this kind of products and also to spread the knowledge and to present these new products in the markets we are present. Okay, this is a few examples of some of our projects that we are working on. This is a range of turbines for orchard sprayers, and the robot we are here with Ineshtek and with Philip. I don't know if you have any questions about this.
It's okay for me.
Okay, so I will pass the presentation to Philip now to speak a little bit about Inestec and also to go more deeper in the solution of the robot.
Okay.
Okay,
Nice.
bye-bye. Thank you for your time.
Thank you.
So now it's time for Inestec. I will not go so much. I will not go too deep. Inestec is an R&D institution, private institution, and we make the interface between academia and companies. Okay. We are more than 1,000 researchers, okay, and our main associate is the main universities of north of Portugal, okay. We are aligned with the societal challenge, namely for industry, technology for industry, technology for sea, and technology for the agro-food sector. In 2014, we have created the Laboratory for Robotics and IoT for Smart Precision Agriculture and Forestry. And in 2014, we have identified that our reality in Portugal needs some relevant machinery and needs special machinery and robotics. And we have also looked for the strategic agenda for Europe in robotics. We are aligned to the main concept of precision agriculture, okay, that is to apply the right amount of quantity of products in the right place in the right time. And we are aware that the main players in the sector, like John Deere class, they are aware that big machines can create soil compactation. And when they are damaged, it brings a high cost for the production system because the whole system blocks. So sometimes we are planting seeds of grams when we and with the tons of machine, a machine with the tons of weight. Okay, so we can make things better with smaller machinery. So our aim in Inestec is to research and develop modular and safe autonomous small machinery, and this is our focus, with three main contexts of application: the Douro region, steep slope vineyards, where we don't have always GNSS solution available, and where the path planning needs to be aware of the center of gravity of the robot. We are also aligned with the greenhouses concept, and like we have in Portugal a lot of forestry, we are also developing robots for managing the forest to avoid big fires like we had in the past. So this is our roadmap for steep slope vineyards. In the first milestone, we want to have robots that are able to do monitoring autonomously, fully autonomously. And at this stage, we are in the second milestone, that is robots for precision spraying in this context. Afterwards, we want to explore pruning and harvesting concepts. For these milestones, we have two platforms, Agrob 16, that is a 1-ton machinery, and Agrob 16, that is a smaller platform that you will see in the demonstration of today. So we have expertise in the navigation, visual perception, advanced control, and safety issues. So let's start the PRYSM concept. So this was the video that we have presented in the beginning of this project. We have joined Rocha, Pulverizadores Rocha, and Inestec towards a new concept of robot for precision spraying. I don't know if you are listening to the sound, but you are listening, no?
No, we are seeing the video without sound. We are listening to you.
Okay, just listening to me. Okay.
That's okay, I think so.
I was trying to sell the sound because the sound of the video was great, but it was not possible to transmit that, but we will move forward. So why we are doing this? Steep slope vineyards, they represent 12% of the area that produce wines in Europe, but they have a strong problem of mechanization of this reality because the conditions are not easy to access. It's a steep slope vineyards. They are placed in slopes terrains, and we cannot put any kind of machinery here. So this brings problems for the machinery itself, the size and the weight, but also brings problems for hydraulic solutions because high temperatures may damage this equipment and produce leaks on the oil. So what we are proposing, a precision robot sprayer that is modular, that is capable to operate autonomously in steep slope vineyards with high efficient sprayer. We are speaking about 100 liters per hectare, and that are able to work in a rocky terrain and that is able to work in a slope terrain, okay? Because we, as I said before, and this needs to be reinforced, these slopes brings challenge for the robot because there is places that is danger for the robot because it might fall, because if it does a trajectory that is not safer. So what are the main innovations? So we are moving from a traditional air blast sprayer based on a PTO to a fully electrical based sprayer. Something that is working with low volume spraying, less than 100 liters per hectare, and that has path planning that is aware of center of gravity of the robot, but the slopes of the terrain. And a robot that is able to localize in these vineyards, even if the GNSS receivers fail, he is able to localize the robot using other sensors like LiDAR, cameras, and stuff like that, okay? And let's see in detail what I mean with this. So, what is the main innovation in terms of sprayers? Traditionally, the air blast sprayers depends on a PTO from the tractor. Okay, depends on this plug, mechanical plug. It has some problems with hydraulic in high temperatures place, like existing steep slopes indoor region. So this high temperature might originate some oil leaks, and the durability of the solution is shorter, and the solution tends to be less precise when we compare to other solutions. It's a bit heavier and creates some problems of maneuvering, okay? So what we have done was to select electrical solution based on so on that will make the solution more compact, more controllable, and more precise, okay? And we believe that is more reliable under high temperatures and more lighter at the end. Okay, so the concept of this sprayer is to be connected to the decision support system that are being developed on the emitter project that tries to uniformize the communication between cyber systems and don't have a closed proprietary solution. So our system is able to receive a prescription map from decision support system, look to the vineyard, and identify what is the real amount needed for that place, okay? And this is done on real time. We have also had a camera. If you want to do a precision spray devoted, for example, for treatment of grapes. So we are innovating these sprayers to be able to treat just the fruit if this is needed. Lauren, you are speaking.
Est-ce que tu peux lui envoyer
I think that Lauren is speaking, but it's not for us. Lauren, you have the microphone on.
Pendant 3 réunions demain matin. Okay. Regardez, moi je suis libre demain matin.
I think that Lauren is yeah. Lauren, you are speaking to us? No. I will continue. I will continue. So our next steps for the sprayer, we have done a great job, I think. But we need. He is saying something, but yeah, activar mode, no? He's very happy. So I think that we have done a great job here with Pulverizador das Rochas to reach a sprayer. For this conceptual proof of concept, we have reached a good solution, but now we need to improve the sprayer, increase the airspeed, and improve the nozzle's properties. So in the robotic side, as I said, this is a common part. This is a robot that is able to communicate with the emitter hub. That is a reference for the European Commission in terms of interoperability in the agro-food sector. This means that we can receive a prescription map and afterwards adapt that what is needed in reality in the terrain. So our robot is able from a aerial image that is extracted, for example, from a Google Maps, identify what is the places where the robot can navigate. And using this map, we can give the path planning without needing the robot visit the terrain, okay? I will not go too much deep in this question, but what we have done was to pick in the state of the art of path planning and add the features to be able to identify what is the path that is more safer for the robot, considering their center of gravity. And if we are thinking about sprayers, we have a liquid inside of a container that will change along the time. So we need to be aware of this. So the robot needs to make the path planning aware that the center of gravity will change along the time. This is a solution making a path planning along in real time. I will not also enter too much detail, but as you can see, it can do a path planning in real time and very fast, in a very fast way, and considering the slopes of the terrain. In terms of localization, as I said before, we want a solution that if, for example, the GNSS receivers fails, the robot can work continuously. And so we need to have a redundant solution based on LiDAR and cameras that is able to identify the localization of the robot using this information. To do this, what we have done, this is a 3D maps that we obtained in this vineyard of Sograp. And from these 3D maps, the robot is able to identify where he is and localize the robot. Okay. So, in terms of next steps, if we go for the next steps, we will improve the sprayer design to make it more a product, less conceptual prototype. Improve the bind slam, integrate this on the robot itself. Add safety systems, because in this first milestone, this was not our concern. So we will have safety systems. If someone appears on the front robot, the robot will stop. Or if an animal emerges on the front robot, the robot will also stop, okay? We will redesign the full robot. Probably we will make as a single structure. And you can imagine this as a sprayer container with wheels, and that has sensors that can go along on the vineyards. So now let's go to the live demo that we had here for what we are here. For you that you are in a remote place, you can plug on that address, okay? If you have time, please put on your browser and let me know if you can access and see this interface. Sorry for doesn't, or I can do it this way. I can share on the chat, probably is better, right?
Yes, yes, it will be better.
Okay, so Nelson and Lohan, have you access to the browser? Yeah?
Not yet. I'm sorry.
Yes, Philippe.
That's great. So, okay, Lauren, you have access, Lauren?
Yes.
Okay, this is the first time. The connection is not the perfect one, but I hope that the things everything goes well. Okay. Now I will pass my talk to Ever. Okay.
Okay.
That will show you inside of the robot where he has the path planning. Okay.
Okay.
Ever, can you please share your screen and start the presentation?
Okay, give me a minute. Hello guys, sorry for delaying.
Okay, I will pick
Okay.
Okay, that's fine. are you seeing the robot moving
We are seeing
on
your email box. Now it's
on
okay.
the
Now
on
you
the
are
interface?
seeing the path, the prescription map.
Can you hear me?
Yes.
Okay, right now I'm trying to show you the nav interface. Here you can see the robot trajectory and its localization right now. I'm asking to Philip. Philip, can you try to show the real robot right now? Sorry guys, this is not the perfect environment to
No, but it's
to
okay.
live demos.
Oh, it's okay.
Can you see the robot right now? Okay, I can show you also the 3D sensor right now. Let me try to. Here, you can see development data. Right now, you are developing a localization algorithm to add to the GNS localization system. Hey guys. Okay, this is the reference, the trajectory that the robot should follow.
Lauren, Ebert, I will ask one question to Lauren, to Nelson. Are you able to see the interface?
Yes,
I
perfectly.
perfectly too.
Right now.
Battery level, map, sprayer intensity, everything.
Tudo.
Yes.
Danger level
Spraying,
0.
Well, I cannot see because I'm with a lot of screens here, but I hope that you are able to see the sprayer with a bar that is moving according if it exists or not a trunk, right?
Right.
So that is a sensing system, okay? When it detects trunk, or here we are in the stage that we don't have a lot of lifts, okay? The condition is not the most appropriate for spraying because, well, it is because if you see there is some lifts behind, but it's in the early phase of the plant grow, okay? And so what the sensor is doing is detecting this wall and adjusting the quantity that will be needed for that region, okay?
Okay.
So the robot is moving. I don't know what you are seeing. If you are looking for Philip laptop,
Sorry, Philip. I lost for some time. I lost the connection.
Yeah. Okay. No problem, ever. So you can end your screen sharing, ever.
Okay.
I saw the path planning inside the Herbert screen.
Yeah. Lauren, I don't know what you have said. Sorry, can you repeat again?
No, I saw the path planning inside the Herbert screen. So that
yeah.
And also we see the HMI, and so we see the sprayer speed,
Exactly.
battery level, velocity. We have the position on the map eye view, so that's quite good. We saw where is it, and also we have the feedback of the LiDAR, I guess.
Exactly.
The front camera.
And what do you see in the camera? Exactly. Okay, so probably the battery level, Laurent, is something that is not connected at this moment because this interface is something that we have made for proof of concept, okay? So the battery level is not yet being published. What is being published is the safety zone, okay? If something comes in the front of the robot, is able to detect if it's something very big or small, okay? Okay, if I click on the prescription map, you will see a prescription that is put on top of the map, right? If you press several times, you will become white, okay?
Yes.
Yes, it's white.
This is a limitation that we have for this interface because in theory, this should happen one time. If you want to get again the map, you need to reload the interface, okay?
Okay.
This interface is a proof of concept. I need to remind you again that has some limitation. I will share my screen because this makes sense because since we are recording the session, probably the guys will see this video, wants to see this also, right?
Yes.
Yeah, you are seeing the same screen that you have in your computer. So on the LiDAR data, that is the black image with the green dots. You will see a red square and a blue square, right?
Right.
Right.
Well, I almost see two red squares. One.
Exactly.
Okay.
There are two indeed. The more intense one is in the front of the robot. The less intense one is on top of robot. So we are not analyzing some data or objects that are present in that level. Okay, we are just analyzing what it has in front of the robot. Okay, and the red one is the safety zone. The blue one is where we are measuring the canopy of the grape that we will afterwards use to apply the product. So now you will see the robot reaching. I don't know if in the video is able to understand how slopey is the terrain on that place. I hope that you can understand from the videos that you are seeing. Yeah.
Can you hear me?
Yeah, but
right now we have like a tricky condition for the robot. If you can see in my camera right now. Can you see the robot in my camera?
Yes.
Yeah, now is the most difficult part. I think the robot can just crash right now, but if it crashes, I don't know if you can see.
Are you seeing how slopey is the terrain, Laurent and Nelson, from video?
Yes, perhaps we don't. Yes, now I can tell that we can see. You know that sometimes each image can be tricky for we to understand the real slope, but I can tell that perhaps we have the idea of what we are talking about.
So the robot was able to transpose that places, and now we'll return again to the base station. Okay, he has made one row, and now it will come again to the other row. Okay.
Okay, I will just use my camera to show the robot right here. Okay.
Okay.
Sorry, Philippe. Are we going to see some image from the robot from outside, the robot in the vineyard?
From what?
The robot not from the inside camera, but some image of the robot circulating in the vineyard or coming to the home base.
It is coming. I don't know if you are Nelson. I don't know if you are seeing the camera from Philippe laptop.
Well, I'm seeing the interface, and in Zoom, I'm seeing the same interface.
But you, Nelson, if you press on the
Philippe laptop, there it is. Okay.
Okay. Lauren, I don't know if you are able to see that camera also. This is being recorded. Okay.
In Eber, yes. In Eber, I can see the robot from outside, as I was asking. Thank you.
Yeah, you are seeing that.
Yes.
So this is the perspective that you have from the robot. Lauren, I think that you are able to see the same thing, right?
Right. No, it's okay. I saw the robot.
Well, on this interface, as I said before, there is some, this is a conceptual interface. You will see the robot on the binary a bit lateral, okay? This is a problem of representation. For the robot, it's not a problem itself, but it's something that we will correct in near future. So, Lauren, Nelson, I don't know if you have questions, because the robot will take approximately 5 minutes to reach here.
5 minutes?
Okay. 5 minutes, I think.
I definitely have some questions. But I don't know if you'd like to take the robot, or we can start talking about the robot.
We can start talking about the robot.
Yeah.
It's better.
Okay, so my first question is more curiosity than anything else. The platform that you use for the robot is a previous platform that you adapt to this task.
Exactly. This is the previous platform that we had in the laboratory where we have put the sprayer. If we go to the second stage, our aim is to put all together and make it one piece from scratch. Design the full design of system.
Okay.
Design the full system.
No. Anyway, I think that it is a very clever solution, and if we can take a previous platform and do the necessary adaptations for the task, it's a good solution because we don't have to start developing new platforms again and again and again. So I think that it's a clever solution, even if you just want to do some adaptation. Concerning the 3D maps, I missed something.
I think that
Nelson, if you allow me, just a small
yes.
commentary about that. And if we go ahead in this, maybe Russia, we have technology to go ahead with the develop of a new tank that will adapt more to the platform and that will adjust better to these difficult rows, difficult slopes. The idea is to create the tank that integrate the platform and create a unique piece of a complete spraying robot,
Okay, very well, thank you.
Thank you.
The other question that I was making is regarding the 3D map. I missed something about the production of such map. This map is produced by the robot, is produced with the help from other data, from aerial data.
This is produced from the 3D LiDAR sensor, Nelson. On top of the robot, there exists one sensor that is 3D LiDAR sensor that will concatenate of course, this is not just concatenate, this is a problem of localization and mapping problem, okay? This is more from the robotic side perspective. The robot is able to localize, and using this localization and what you see on the LiDAR, it can produce a 3D map.
Okay. And the prescription map is connected to this 3D map, correct?
No, the prescription map is another issue, okay? We see, like we have on the traditional equipment, that we have a prescription map that comes from the decision support system, like a GeoTIFF image, okay? Well differentiated with the quantity of product that we need to apply on that place. So the system is able to interpret this prescription map. What we have done differently is accept something that is called ISO XML files, but also accepts prescription maps that are standardized according to the Demeter project, okay? That is the European umbrella for interoperability on agricultural sector, okay?
Very well. And talking about autonomy, in which point are you? Which point do you think that you can achieve?
Well, the robot is navigating at this moment fully autonomously, okay?
No, sorry, Philip. Bad question. I was talking about battery autonomy.
Okay. That's amazing.
Sorry.
Well, that's an amazing question. Okay, I was understanding on the point of view of autonomy of robots. In terms of power, this is more related to Inestec, but we are cooperating with Varta, and we are trying to pick the lithium technology to this kind of robots, because the lithium batteries are more light and they have some benefits when we are working with powerful motors that we have on these platforms. The sprayer has a powerful motor, okay, that requires a lot of current on the beginning of its actuation. So then we are working on lithium batteries, and our move is to go there. And if we redesign the whole system again, we will consider this kind of batteries. They are a bit expensive, but they have long benefits in long terms.
So, but we are
I don't know
talking
if
about
Nelson.
some hours of working.
Some hours. At this moment, we are speaking about 3 hours, right?
Okay.
I will ask here to the colleagues, but we have changed the batteries today, but we are operating here from the 11 of the morning. We have just moved the batteries and replaced the batteries just for to ensure that this will not finish in the middle of the demonstration. But we have already worked between 2 hours and a half and 3 hours.
Okay, but what I have seen is that you have a lot of margin to go further with the autonomy with this cooperation with Varta. So it looks like that is not an issue to me. Another thing that I was to asking, it was about the maximum slope that this robot could go through. But what I have seen is that in this vineyard where you are, I saw the robot maneuvering in the quite a tricky path. So I wouldn't say that it is concerning to me. But anyway, if you'd like to mention some maximum slope that the robot could go through, I'll thank you.
Nelson, during your question, there was passing a tractor behind me, so I don't know if I have understood the whole question.
I was telling that is not this question is not an issue to me, because I saw what the rover, the maneuver that he did between two lines. Anyway, if you'd like to mention some maximum slope for operation, it will be useful.
On its stage, at this actual stage, if it has fully with water or liquid for spraying, probably I can ensure 30%, 30 degrees. But it depends how it approach the. I have colleagues here saying that we can go more, but it depends how you approach the slope. Okay. Of course, if we go for the new version, we can improve this.
Okay, very
well. The robot is reaching now to the base station. Okay. And I think that we can go and see details the sprayer. Oh, André, queres ligar o publicador? Queres chegar lá ver? Ligar? Sim, sim. Vai para lá ao fundo. Pronto. So, are you seeing the road is reaching now to the place? As you can see, sometimes he slips, but he can recover for the trajectory. Okay. Okay. I don't know if Lauren wants to ask something, or Nelson, please. Meanwhile,
I'll let Lauren to speak a little bit.
No, it's okay, Nelson. You ask a very nice, interesting question. So you talk about the autonomy of the system. That is important for me because I think for the vineyard you need to make the spraying for all the parcel. So you need to be able to do that. What is the maximum speed of the system?
The maximum speed is 1 meter, but we don't trust that is the safer velocity maximum safe. So we don't believe that 1 meter per second is safer. So we believe that the most safer velocity is 0.5 meters per second.
Okay, and for the process is good?
For the process, we believe that it is, because if we want to do 1 hectare, we are speaking about roughly 4 kilometers. Okay, so I need to make a calculation again because I'm a bit confused, but it does in 2 hours, 1 hectare. So you can see if it's feasible or not. We can increase the speed, but this will have impact on the design of the sprayers itself, okay, and in the safety level of the system.
Okay.
And if we want, that is a robot that is able to operate in open environment, and that is weighs at least 200 kilograms. In terms of safetiness, probably it's better to go below 0.5 meters per second, okay? Because 1 meter per second is a velocity that we consider a bit higher to ensure the safety level of the system.
And according the if we have some raining day, is it possible to use the robot in the floor that is wet, or is it better that the floor is hard? Or
that is a good question. We have already tested this with the rainy terrain, and the robot tends to slip, slippage, to
Okay.
create some slippage. But this is a design that we need to figure out in the second version or the second iteration, because this is a static and rigid platform. So the four wheels are static. So we need to think that exactly more with a joint in the two wheels to ensure that the four wheels are always in contact with the terrain. Okay.
Okay.
I don't know if Lauren, it was clear my answer.
I understand. Yes, it's okay. So that's good. And regarding the compression of the floor, is it one important point or not really?
For the
compression of the floor?
If it's rocky or if it's soil or terrain,
yes.
right?
Yes.
Is a mix. The robot, I don't know if you are able to understand or what kind of terrain you have here. Lauren, for you, probably you are not. Are you seeing my camera?
I see that.
Are you seeing this kind of? This is not. Okay.
Okay, perfect.
And you have a mix. This is not a fully. Are you seeing, Lauren?
I see. It's different. Okay.
As you can see, this is not just, and you can see. So you have a huge very hard area to work.
Okay.
The place is very difficult. Like you see, the terrain also complicates a little bit.
Yeah.
But I think the machine makes a good job. Yeah.
Yeah.
Okay. So for me, it's okay. I have no more question. Nelson?
Can I make you another question?
Of course.
So the question is concerning the refilling of the tank. Do you have some control about going to refill, about the volume of the treatment that you still have in the tank, and autonomy for the robot to know that he needs to refill and go back to be refilled by some operator?
At this stage, we don't have that on the project. That is a second part of the project that is planned for PRYSM project. If we go for the second stage, besides the safety questions, we will have a docking station for refill and charging the robot itself. Okay. In terms of robotics, it's not a very hard issue because there is technology and the LiDAR is one of that technology that we can use for autonomous approach the docking station. But it's something that we need to figure out what is the best design for the docking station because it needs two plugs to kinds of inputs, water with the product to apply and energy. So. But this is for the second stage of the project. We have not think about yet, but we have solutions from industry side and from other projects that we have on the ongoing, so we can try.
Okay, thank you.
So from our side, I don't know if Lauren has more questions or if Nelson has. We have also our colleague Mario Cunha here in the presentation. I don't know if Lauren wants to make some question or if it's okay.
For me, it's okay.
Okay. So from our side, if you don't have questions, neither things to ask, we can consider the session closed, right?
Well, I'd just like to give you congratulations because I think that you are responding in a good way to the challenge that you provide. And yes, I would like to felicitate the development that you did with this robot. But anyway, I have no more questions to make. For me, it's fine what we have explained, and most importantly, what I have seen. Because seeing the operation is the best way to evaluate what you are offering.
Yeah.
Anyway, congratulations.
Thank you, Nelson.
Thank you.
You're welcome.
And also, thank you for the presentation because it works. So no real issues. So the HTML, the user interface works. So the feedback of the video was quite good. And I have one question for Nelson. If you need to buy this kind of system, are you interested for that?
So, sorry, I couldn't understand your
yes,
question.
Yeah. For this system, if you need to buy it, like you are the challenge provider, so are you interested to buy this kind of system for the future?
Well, I have to tell you, when the autonomy question is more developed, I think so. I think that this, well, anyway, we are an association, but I will tell that with this question of the autonomy more developed, this is definitely be interesting to be bought by some of our associates. Well, but there's always the question of price, and I think that at this point they don't still have a reference price, because when we talk about companies, companies talk about profit, and if they are talking about profit, they are talking about price. So this will, I will be interested, yes, but this will definitely depend on the final price. The price perhaps will depend on the number of the units produced, and we have more buyers, there will be certainly more cheaper. If it will be a single or a couple of units, it will be more expensive. But I don't know if at this point Inesktek and Russia could provide some number. I don't think so. But if you want to try,
this moment, it's in this moment from our side, it's really very difficult to go ahead with the price because, and like Philip told you first, it is very conceptual. If we pass to the second phase, we will try to make the machines better to go to production, and of course with that we will be able to define a price or even a price target. At this moment, we don't have. But I don't know also if you, Nelson, you have any idea of a kind of price target for this type of products? Or
no, I wouldn't take the risk, because it will depend on the speed.
Okay.
Because the speed will depend of the numbers of hours of working hours that I'm not spending. So at this point, I wouldn't risk some price, because it will depend.
Okay. Okay.
But anyway, since we are, I have to mention that since we are so much lack of working power, mainly here in Douro, that's a very difficult question. And I've seen some companies that are developing solutions that are very expensive, and they are telling, for now, this is not feasible. Anyway, I know that tomorrow I'll not have workers at all, and at this point, I'll need such technology. And that's another thing that we cannot control it, and that will make the prices go up or go down, because there will be some point where people will not have the choice between working hours or machinery. They will have to go to machinery. So I'll say that at some point this will be a valuable asset for the sector.
No, Nelson, I agree completely with you, and I believe that this type of solutions will be the future, and maybe not too long in the future. Maybe in a few years we will need this type of solution,
yes, in the
and
next
this
few
will
years, I'll say.
Yeah. Okay.
So Laurent, I don't know if this was the answer, but I think that is the possible answer at this point.
No, of course, but no, it's okay. It's perfect.
Okay.
One important point also for the phase 2 to know if the channel provider is interested by this kind of system or not. And of course, we need to, the phase 2 is here to need to create the the target price, and to analyze the market also. So this is one important phase for the next step. So
of course,
that's why I ask this question also.
Okay.
Yeah, indeed, is that is more feasible for this was a proof of concept, and now afterwards, if we move to the second step, is where we can analyze in more detail what will be the right target price and even the market, because this doesn't apply just to the steep slope vineyards. This can be applied also in flat vineyards. So this is not just a product for steep slope vineyards. So the market is not confined to steep slope. So I think the market is not so strict.
No, and the solution, I think, that combines two different things. One is the robot, of course, and the other is the electric spraying. No, and that is also a good thing now for the robot, but maybe also for another type of applications.
Okay.
Yes.
Okay.
Yes, that's a point also.
Yeah.
Okay, for me it's okay.
For me it's okay as well. So,
from our side, thank you.
Thank you very much for this presentation. So I think you need to work hard until tomorrow.
No, don't say that. I will make a direct night to do it that. But no, but tomorrow I will send the documentation. I think that I have until the till the midnight of tomorrow, I think, right, Lauren?
Right.
So I will do my best, and we will close the administrative forms. And I hope to see you and in 25 or 26 of April to the final presentation. That's it.
Yes, after that you push inside the Esmeralda dashboard all the documents. So I review it because I need to validate myself. And if I have some comments to do, so I inform you this week. And after also, Nelson, you need to make some evaluation of this presentation, and myself too. And after, you need to prepare the presentation for the evaluator, for the evaluation session also at the end of April. I think it's 24, 26 April, something like that, if I remember.
Yeah, exactly. 26, but that is for now.
Oh, 26.
Yeah. Well, well, let's so we can close the session, right, Lauren?
Right.
We will need to pick the robots, put in the car,
and start working on the report.
And start working on the reports, exactly, to finish the reports and send to Lauren.
Okay, thank you, Nelson. Thank you, everybody.
Thank you.
Good job.
Okay, thank you. Bye-bye.
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 Bye.
Eu acho que isto é só encerrar, espero que isto tenha gravado.